In this video, I want to have a look at simple and compound interest. So these are both things that you've seen before, but just to jog your memory and have a look at them through the lens of series and sequences. So to start with simple interest, the formula that we need is I equals PRN. So I stands for the amount of interest, P is the principal or the original amount of money, R is the rate, and we need to make sure that we're writing that rate as a decimal. So if it was, say, 4%, it would be 0.04. And our N is our number of time periods. Now, it's important that this is just finding the interest that's earned, not the total amount of money that you have at the end. All right, so with simple interest, it's going to form a linear function. And the interest at the end of every single time period forms an arithmetic progression or an arithmetic series. All right, so let's have a look at a problem involving simple interest. So our first question asks us, it says $5,000 is invested at 3.4% per annum, so per year, simple interest. What is the value of the investment after 7 years? So this formula isn't on your formula sheet. You need to know it and know when to use it. So in this one, our $5,000, that's our principal. Our 3.4% is our rate, which means that our R is 0.034. And our 7 years, that's our N. So our formula, plugging those numbers in, is going to be I equals 5,000 times 0.034 times 7, which will give us an answer of 1,190. Now this isn't our final answer though, so we just have to be careful of what the question's asking us for. So it's not asking us how much interest is earned over 7 years, it's asking us what the value of the investment is. So we've earned $1,190 interest, but we also have our original $5,000. So the total amount at the end is our $5,000 plus our $1,190 interest to give us a total of $6,190. Our second example says Emma invested a sum of money in an account that earned 4% per annum simple interest. After 5 years, she had earned $860 interest, and we need to find out how much money she invested. So this time we've been given our interest. We know that our rate is our 0.04 and our N is our 5. And what we're trying to find is that P in our formula, the principal. So we're going to have to work backwards, but we can substitute in what we know. So our 860 is going to be equal to P times 0.04 times 5. Now you could figure this out now if you want to, so simplify this a little bit and then divide 860 by your answer. I'm just going to write it out without simplifying it down. So I'm going 860 divided by that 0.04 times 5. If you're putting this in your calculator, just make sure that it is doing what you need it to. So on some calculators, you might need the brackets around the denominator there. So if we pop that in, we'll end up with 4,300. So she initially invested $4,300. Right, if we have a look now at compound interest. So compound interest, this formula is on your formula sheet. So it's got AN, which is now the total amount that you have at the end of the time period. So it's not just looking at the interest, it's the total now. We've still got our P for principal. Now the way they've written this formula here, which is the way it's written on your formula sheet, that R is the rate and it's the over 100 that's turning it into a decimal or a fraction. So if it's say 6%, you'd write 6 over 100. If you want to ignore this and just write 0.06 instead, that's fine, but you just need to know that that's how it's interpreting it in the formula that's on your formula sheet. And our N, again, is the number of time periods. It is really, really important when you're talking about compound interest that your rate and your number of time periods are in the same units as the investment is being compounded. So sometimes it's being compounded annually, so our rate and our number of time periods both need to be in years. If it's all being compounded monthly, they all need to be in terms of months. All right, so our simple interest was a linear function. Compound interest is an exponential function, and that's because the amount of interest you're earning each time period is bigger each time. And the total amount at the end of each time period forms a geometric series. So let's have a look at an example. So our question says, Ryan invests $8,000 at 6% per annum compounded monthly. Part A asks us how much will be in his account after 6 years. So for part A, we're going to use our formula, which was A equals P outside of 1 plus r to the n. Now I've simplified that, but we could have it as over 100 if we wanted to. Substituting in our principal was our $8,000. We've got 1 plus. Now this bit's really important because it's compounded monthly. We need to have everything in terms of months. So that means because we're looking at it at the end of 6 years, our n would actually be 72, so 6 times 12. The other one is our rate, so it's 6% per annum, so for a whole year, but we only want to know that rate per month instead. So we would have to divide that by 12, so that would give us 0.5%, so 0.5%, which as a decimal would be 0.005. So you could write that as 0.5% if you'd like. So I'm going to write it as 0.005 to the power of 72, and that's going to give me $11,456.35. So that's the total amount in the account, the original $8,000 plus any interest earned. So that leads us into question B, which says how much interest did they earn over that time? So the interest is going to be this new amount minus the original amount. So $11,456.35 minus our $8,000 principal will give us $3,456.35. All right, part C asks us after how many months will his investment have reached $10,000? So that $10,000 is going to be our A in our formula. This is question C. We're going to have $10,000 equals our 8,000 outside of 1 plus 0.005 to the power of n, and we need to figure out what that n is. So first off, I'm going to divide both sides of that equation by 8,000. So I'd end up with 1.25 equals, and over here I'm just going to simplify this to be 1.005 to the n, just to make it a little bit cleaner. Now we need to get that n on its own. So there are the two different methods of doing this. It's up to you which way you do it, but we are going to use logs. So if we take the log of both sides, we'd have log of 1.25 equals log of 1.005 to the power of n. Now we can bring that n down the front using our log laws. And then to get the n on its own, I'm going to divide both sides by this. So I'm going to have n equals log of 1.25 divided by this one, so log of 1.005, and that's going to give me 44.74 and so on, which means that his investment will have reached $10,000 after 45 months. All right, the last little thing you need to know for this video is depreciation. So when we're looking at compound interest, we're often looking at things that are gaining interest, so they're going up in value over time, but sometimes things are losing value. So you might have bought a car and it's going down in value over time. So that then we say that it's depreciating. So this formula isn't one that you get given, but it's exactly the same as the compound interest formula, except we have a minus instead of a plus. So the questions work in a similar sort of way. So that's having a look at simple and compound interest.